Welcome to What If, the show that explores the boundary between scientific possibility and sheer imagination. I'm your host, David. Each week, we take a hypothetical question and push it to its logical and sometimes terrifying conclusion. Today, we're tackling a question that bubbles up beneath one of America's most beautiful national parks. It's a place of breathtaking geysers, vibrant hot springs, and abundant wildlife. But beneath that serene surface lies a geological monster. Today we ask, what would happen if the Yellowstone Super-Volcano suddenly erupted? To help us understand this planetary scale event, we have a very special guest. Dr. Albert Chambers is a geochemist who has spent over 20 years studying the Yellowstone Caldera. He's one of the world's leading experts on supervolcanoes. Albert, thank you so much for joining us.
It's my pleasure, David, though I'll admit it's a sobering topic to discuss.
I can only imagine. So let's start with the basics. We all know what a volcano is, a cone-shaped mountain that spits lava. But Yellowstone isn't like that. What exactly is a supervolcano?
That's the fundamental difference. A supervolcano isn't a mountain at all. It's a depression, a giant crater called a caldera. It's formed when a massive magma chamber, miles beneath the surface, erupts with such force that the ground above it simply collapses into the empty space.
A depression. So the evidence of the volcano is the hole it leaves behind.
Precisely. The current Yellowstone caldera is enormous. We're talking about 30 by 45 miles. It's so large you can't even perceive it when you're standing in it. You just think you're in a vast forested basin. But what you're standing on is the lid of a gargantuan magma chamber.
How gargantuan are we talking? Give us a sense of scale.
Our seismic imaging suggests there are two chambers stacked. The upper one is about 55 miles long and 25 miles wide, and it's anywhere from 3 to 9 miles deep. To put that in perspective, you could sink the entire city of Chicago in it and still have room to spare. And it's filled with mixture of molten rock, solid crystals, and dissolved gases, all under immense pressure.
Good heavens. And all the geysers, Old Faithful, the hot springs, that's all just a heat from this monster leaking to the surface.
Yes, they are the beautiful and somewhat menacing signs that the system is very much alive. It's a living, breathing volcano, and it has a history of violent eruptions. The last super eruption was about 640,000 years ago. Before that, 1.3 million years ago. And before that, 2.1 million years ago.
There's a rough pattern there. People see those numbers and get nervous. They think we're due for another one. Is that a fair assessment?
It's an understandable fear, but volcanoes don't work like clockwork. Geologically speaking, these are just averages. The truth is, the annual probability of a Yellowstone super eruption is estimated to be about 1 in 730,000, though it's far more likely to be struck by a large asteroid.
That's somewhat reassuring, but not zero. So if it were to begin stirring, would we have any warning?
Oh, absolutely. This isn't something that would happen out of the blue. The Yellowstone Volcano Observatory is one of the most heavily monitored volcanic systems on the planet. We have GPS stations measuring ground deformation to the millimeter, seismometers listening for earthquakes, chemical sensors in the gas vents.
And what signs are you looking for? What would be the red flags?
The first major sign would be intense and sustained ground uplift. We're talking feet, not inches, over a short period. This would indicate a significant injection of new magma into the chamber. Then you would see intense earthquake swarms, thousands of them, becoming shallower and stronger. You'd also see dramatic changes in the hydrothermal system, geysers erupting differently or stopping altogether, new steam vents, we call them fumaroles, opening up, and a massive increase in the output of volcanic gases like sulfur dioxide.
In your career, Albert, has there ever been a time where the instruments lit up and you and your colleagues felt a genuine sense of alarm?
Alarm is a strong word. Let's say heightened professional interest. Between 2004 and 2008, the caldera floor was rising at the rate of nearly 3 inches per year. That was the fastest rate observed since we began detailed measurements. It caused quite a stir in the geological community.
Right.
Then, in 2010, we had an earthquake swarm under Yellowstone Lake with over 2,000 recordable events in about a month. The combination of those two phenomena, yes, it certainly had our full attention. But the activity eventually subsided. It turned out to be magma shifting and hydrothermal fluid moving around, not a prelude to an eruption. But it was a stark reminder of the power we're observing.
A reminder of the stakes, which brings us to the core of our show today. Albert, let's imagine those warning signs don't subside. The ground swells, the earth shakes, the gases pour out. It's happening. Take us to that moment. What would the eruption of the Yellowstone Super-Volcano look like?
It's difficult to truly comprehend the scale. This wouldn't be an eruption, it would be a cataclysm. The event would be rated an 8 on the Volcano Explosivity Index, the highest possible value. The last eruption of this magnitude on Earth was Toba in Indonesia, 74,000 years ago. The eruption would begin with a blast that would shatter the sound barrier many times over. The sound alone would be deafening for 1,000 miles. A column of ash and rock would be ejected 20 to 30 miles into the stratosphere. But the most immediate deadly threat would be the pyroclastic flows.
You mentioned the Toba eruption. For our listeners who might not be familiar with it, could you paint a picture of what that event was like and what it did to the planet? Describe those for us.
Imagine a ground-hugging avalanche of superheated gas, ash, and rock moving at hundreds of miles per hour. The temperature inside these flows would be over 1,000 degrees Celsius. They're utterly unsurvivable. Anything and everything in their path, trees, buildings, people, would be incinerated instantly.
And how far would they travel?
Based on past deposits, we estimate the flows would extend out 50, maybe even 100 miles from the caldera. The entire Yellowstone Park and the surrounding towns, Jackson, Wyoming, Bozeman, Montana, would be gone in minutes. It would be a kill zone from which there is no escape.
My God. And for the rest of the country? For those outside that immediate kill zone?
For them, the danger is the ash. The eruption would pump an immense volume of pulverized rock and glass into the atmosphere, over 1,000 cubic kilometers of material. Prevailing winds would carry this giant cloud eastward across the United States.
Those cities like Denver, Salt Lake City, what would they experience?
Within hours, they'd be plunged into total darkness as the ash cloud rolls in. Then the ash would begin to fall like a thick, gritty, gray snow. We're talking several feet of ash blanketing states like Wyoming, Montana, Idaho, and Colorado.
And this isn't like snow. It doesn't melt.
Not at all. It's abrasive, corrosive, and
Heavy. Especially when wet. It would collapse most buildings. It would clog every engine and filter, grinding planes, trains, and cars to a halt. The power grid would fail as the ash shorts out transformers. Water supplies will be
contaminated and undrinkable. Breathing the air full of microscopic glass shards would be lethal without filtration masks.
So a huge portion of the United States becomes uninhabitable.
Essentially, yes. Further east, the deposits would be thinner but still devastating. The Midwest, America's
This breadbasket would receive several inches of ash, rendering all agriculture impossible for years, maybe decades. Cities like Chicago, Minneapolis, even New York
would see a few inches of ash, enough to paralyze them completely. All air travel would cease globally.
That's an apocalyptic vision for North America. But this is a global event you're describing. What happens to the rest of the world as this ash cloud spreads?
This is where the true long-term horror begins. The sheer volume of sulfur dioxide and ash injected into the stratosphere would create a fine aerosol veil that encircles the planet. This veil would reflect sunlight back into space.
Leading to a volcanic winter.
Precisely. Global average temperatures would plummet. Bottles vary, but we could see a drop of 5 to 10 degrees Celsius. That doesn't sound like much, but it would be catastrophic. It would trigger widespread
Multi-year crop failures.
monsoon seasons in Asia could fail. Growing seasons in Europe and North America would shorten dramatically or vanish.
And that means
That means global famine on a scale never before seen. With the world's leading food exporter, the United States,
states crippled and global agriculture in chaos, the food supply chain would shatter. Billions would be at risk of starvation. This is what we mean
by
by
a civilization-level event. It's not just a disaster, it's a fundamental threat to our interconnected global society.
Albert, that is a profoundly bleak and terrifying picture. After leading us through that scenario, I have to ask, is there any good news here? Is there anything that we can hold on to for reassurance?
Yes, there is, and it's important to end on this. The first and crucial point is the probability. The odds are overwhelmingly astronomical.
Economically against this happening in our lifetime, or our children's lifetimes, or even their children's. We are talking about geological time, which is vast and slow. So we shouldn't be losing sleep over it tonight. Absolutely not. The second piece of good news is that we would have warning. An eruption of this magnitude would likely be preceded by years, possibly decades, of escalating unrest. It would give us time to prepare, to plan, to mitigate the consequences.
Consequences as much as humanly possible. Our understanding of volcanism is growing every day. That knowledge is our best defense.
So the work you and your colleagues do is our planetary early warning system.
In a way, yes. We study these systems not to fearmonger, but to understand. Yellowstone is a place of incredible natural beauty, a testament to the dynamic and powerful planet we live on. It deserves our respect and our scientific curiosity, not our fear.
A perfect place to leave it. Dr. Albert Chambers, your insights have been both chilling and absolutely fascinating. Thank you for sharing your expertise with us today.
Thank you for having me, Dit.
That's all the time we have for today's What If. Join us next time when we'll be asking another mind-bending question. What if we made first contact with an alien intelligence and they were completely silent? Until then, I'm David. Thanks for listening.